Welcome to Emtron's online video tutorials. This video will cover basic ECU configuration. Emtune comes with default calibration files for both KV and SL series universal ECUs when the software is installed. These are good starting points for creating a new calibration file for your project if you're starting from scratch. If you are using a plug-in ECU, then a base calibration file will be preloaded into the ECU. When connected to the ECU, simply open the ECU and Save File to create one you can use offline. When you open a file, the software will default to the Tuning tab. Airflow tables, ignition mapping, and everything else tuning related is in this section. When using Emtune, if you follow the tabs from left to right in each section, you will generally have the most success completing the calibration fully. It is very important to quickly catch on to this method of configuration. You will notice the software is very intuitive, even with complicated setups if you employ this mentality. When you open the ECU or open a file, the ECU starts out right in the VE table, which is one of the most important functions of the fuel model. This table can govern a major part of the air mass calculation, which will affect the delivered fuel to the engine. These air mass calculations can also be used in other sections of the calibration. For example, the ECU can use calculated air mass for spark load. Since this video is covering the configuration process, we need to move over to the Config tab. Remember, following the left to right mentality, as mentioned before, will provide the greatest success for ECU configuration. The Engine Setup tab is where you configure the entries for number of cylinders, engine displacement, firing order, and more. This is also where you set up the trigger decoding for the engine type you are using. We have an extensive list of triggers currently supported. Select the system that suits the engine you are using. Selecting the decoding also pre-configures the crank and sync sensor type as well. Unless your project is customized in some non-standard way, you should not need to change these settings. Please note that even though we support many different trigger types, the crank index offset position must be checked with a timing light every time without fail. In this section, you can also quickly calibrate the throttle and pedal sensor open and close positions. These functions populate the calibration tables under the Input Setup, which is covered later in this video. Once done with Engine Setup, moving from left to right brings us to the Fuel config. Here you set up your injection modes, fuel types, injector size, and other factors that are very important to the ECU's fuel model. Now is a good time to elaborate on some of the advanced features Emtron offers, especially since one of the shining features of this product is the fueling model functions. The ECU allows multiple configurations for injection mode: sequential injection, non-sequential injection, full sequential staged injection, sequential with group stage injection, and more. The Stoich mode setting allows you to select from a variety of fuel types, but at the same time you can create a customized 3D table using any runtime to manually configure the fuel stoichiometric ratio. Even though the custom table is often used for flex fuel setups when mixing gasoline and ethanol, the table config is very flexible. As with all table configurations in Emtune, any one of the calculated runtimes can be used for access config. The injector nozzle reference pressure is adjustable. This is helpful if injectors located are pre-throttle or pre-forced induction. The nozzle pressure tells the fuel model how to apply differential pressure compensations. This function adjusts the commanded pulse width to match the requested fuel flow. Secondary injectors have their own setting for injector nozzle reference and fuel pressure sensor input as well. This is because some applications have the possibility of using different fuel types for the secondaries. Please keep in mind that if fuel pressure sensing is being used in the fuel model, the secondary injectors must be assigned a fuel pressure input as well. If your primary and secondary fuel systems share a fuel delivery system and you only need one pressure sensor, then the input must be copied so both fuel pressure sensor inputs are used. More details about input channel configuration will be covered later in this video. The ECU needs to have a reference pressure for injector flow as well. The reference flow of the injector should match the reference static pressure parameter. The reference static pressure is the base setting the differential fuel pressure correction system will use if fuel pressure sensing mode is enabled. Select the type of fuel model you choose to use. Several modes are supported from speed density, mass airflow sensing, throttle mass flow, and more. See the help file and ECU release notes for details on these. Assign your injector channels, configure custom storage if selected, adjust your injector dead time, and short pulse width table. The injector dead time and injector linearization table are very important to the fuel model regarding its fuel mass calculations. Like any other fuel model system, it will only be as good as the data you provide it with. Great care should be taken in characterizing the fuel system as extensively and as accurately as you can. When using peak and hold injectors, those settings can be customized here. Lastly, you can also test injector channel from this menu. Please keep in mind that the fuel channel may not match the cylinder you have assigned under injector channels. The Ignition tab has a similar feel to the Fuel Configuration section. You can change your ignition modes from direct fire, waste spark, distributor, and more. Firing edge configuration is also here. The firing edge tells the ECU where to synchronize the timing of spark. This setting is very important depending on what kind of ignition system you are using. There are also settings to clamp the maximum ignition advance and retard here as well. Like fuel, you can select which channels you want to use to drive the ignition system. Ignition coil dwell time is also set in this section. There are two dwell tables that can be controlled with cal slot control, each one with their own offset tables. The ignition test mode is similar to the injector test as well. Again, the injection channel may not match the cylinder you have assigned. Channels is where we configure ECU inputs and custom run times. Let's start with setting up inputs. Once the input setup config is open, notice the order in which the tables are labeled. This follows the left to right mentality as mentioned earlier. Under the Engine tab, you will find a list for all your major sensor inputs. Let's go through Sensor Setup to demonstrate how to configure an input. Under the manifold pressure channel, you can see you have a number of settings. Inputs for analog volt sensors and some others have this kind of setup screen. At the top left, you can select your input. All of the ECU's input channels are available. Included in this list are also CAN inputs that can be configured if using CAN bus expansion devices like our Emtron ECU. Pull-up inputs are most commonly used on temperature inputs as seen briefly here under Engine Temperature Sensor Setup. You can also then select the calibration type. When set as predefined, you can select from a list of many popular sensors that are commonly used in the motorsports industry. If you have a special sensor that requires a custom calibration, select Custom, and then on the top right you can characterize the sensor with great detail as our calibration table has 20 points for entry. A low and high clamp can be enabled for the sensor output runtime. Finally, every sensor in this section has a highly comprehensive fault configuration. You can set fault voltages, high and low, detection time, substitute fault value, and more. On top of that, you can also control how the diagnostic trouble code function will behave when a fault is detected. When a sensor goes into fault ranges, it will set a DTC. AutoClear will automatically start using the sensor again when the fault criteria is not met. Manual clear will follow the substitute's fault value until a PC is connected and the faults are cleared manually. Every sensor also has the ability to trigger a limp home limit table as well. This adds another layer to protecting the engine in the event of a sensor fault. Major sensors like manifold pressure and throttle position also have the ability to enable a fault table. The fault table allows the user to span a small map to assign different substitute values using whatever runtimes they want in the access config. The fault value can be an active number instead of a static value. This is especially useful if there is a need for the engine to be used during a sensor fault situation. The Vehicle tab has inputs not related to the engine. Configuration of these inputs is the same as the Engine tab. When configuring inputs in the Switches tab, the input configuration changes. Again, you can select any of the ECU inputs here. Using digital inputs for switch functions is recommended. The sensor type can then be selected. Momentary switch type will latch the selection in memory until the input is switched again, while switch mode will operate only when the input is active in its arming threshold settings below. If pull-up is needed, you can select this here. See the ECU specification sheet for pull-up voltages for different inputs. Arming thresholds allows you to select a 2-point voltage configuration, or you can select a single access table depending on the input you are using. The rest of the tab's input configuration is dependent on the input style, switch, digital, or analog. They will all have similar configuration screens like the ones we have just covered. Different kinds of digital inputs like VVT signals and speed inputs must have the proper sensor type appropriately selected. If configuring a speed input, there is also a scaling option to convert the pulse count into the correct RPM or speed runtime like kph. See the help file for calculating the scaler correctly. Under Channels, there is also a Calculated Runtime tab. In the main configuration, you can assign appropriate calculations to 2 different runtimes here. The efficiency calculation runtime is most commonly used for spanning the y-axis in different tables in the Tuning tab, most commonly the VE table. You can select from a number of calculated runtimes to determine what the efficiency calculation will emulate. The Load Calculation runtime can be used to calculate access in the Tuning tab as well. This is most commonly used for ignition load. The map-modeled, manifold pressure estimate, and exhaust pressure estimate functions are for more comprehensive fuel modeling configurations. See the help file or associated tutorials for setup and highlights for those functions. The Functions tab is where we configure and enable all the ECU outputs and functions. If you select a system that requires output configuration, this is where this is set up. If the function needs more than one output, then all the channels must be appropriately selected and configured. Polarity and frequency of PWM outputs is configured here as well. Any output pin of the ECU can be set to drive different functions. Please see the ECU specification sheet for output capability and compatibility. Some ECU functions do not require outputs to be assigned, but must be turned on here to enable configuration under the Tuning tab. This is very important to remember when using the ECU, as if a function is not available for tuning, it must be turned on here first. For example, if you are looking to configure an engine protection feature for oil pressure, you must realize that this is an ECU function and therefore must first be enabled before it can be used. Some advanced ECU functions have switch inputs that can be assigned to turn them on and off. This way, the function is enabled and can be fully configured, but its state of operation is controlled with these input switches. Functions that have enabling switches under inputs are always on if the input is not configured. For example, if you enable motorsport traction control, but do not have a traction enable switch configured, the traction control will always be on. Inputs can also be copied and used in multiple places. A more comprehensive method of using one input for more than one function would be to set up a switch function and a rotary position input at the same time. This is possible for something like a traction control rotary trim potentiometer. The rotary potentiometer position is first characterized as an analog input channel. As you can see here, the second position voltage is active over 0.5 volts. Under Switch Function Setting Up Traction Enable Switch, you can set the function to on when the voltage of the same input is over 0.5 volts. This will make the traction control system inactive when the rotary switch is in position 1 or under 0.5 volts. Earlier, we mentioned that if one fuel pressure sensor is used with stage injection utilizing the same delivery system, the input can be copied as well. This is done by configuring both fuel pressure sensor inputs with the same input pin. Finally, the Communication tab is where you can configure communications for each CAN bus channel. Here you can select from a list of pre-configured devices like our Emtron CAN modules, or configure custom datasheets for other components as well.